Okay, for today I want to take a look at these electron energy levels, sublevels, and orbitals that we introduced last week. And I want to give you a little more detail than the book does. As my jumping off point, I'm going to use this slide we ended up with, saying that, okay, just reminder, we have from the Bohr model, level 1, 2, 3, 4, 5, 6, and so on. Those levels are given the symbol n in Schrodinger's equation. It's called a quantum number. In this case, the principal quantum number. Now, um, if you take those levels, you can, like they show on the PowerPoint, like the rungs of a ladder, those levels break up into sublevels. That's something Bohr's model didn't include, and one of the reasons why his model failed. But those sublevels are given the designations SP, D, and F, letter designations from spectroscopy. Those sublevels can be further divided into what we call orbitals. And each orbital can hold electrons. Turns out each can hold 2 electrons for reasons we'll look at tomorrow or the next day, whenever. So that's the relationship between those terms. A level is the energy state, a sublevel is a subdivision of that, and then an orbital is a subdivision of the sublevels. Now, it turns out, for reasons I'll show you just in a moment, that each level is going to hold within it n squared orbitals. So if I'm in level 3, there's 9 orbitals, 3 squared. Since each orbital holds 2 electrons, there's 2n squared electrons in a level. So level 3 holds 3 squared is 9 times 2 is 18 electrons total. Now, let me draw you a bit of a diagram to show this. Let's start out, rather than showing the whole ladder, I'm just going to draw the rungs. Level 1 is down here at low energy, so n equals 1. Level 2 has higher energy. Level 3 and level 4, now they're getting closer together as they go, you'll notice. In reality, they get even closer than I show it there, but I have to spread them out so I can fit all the subdivisions in there ultimately. Now remember, these 1, 2, 3, and 4, those are the n values. Above 4, there's n equals 5, n equals 6, n equals 7, and so on up to infinity above level 4. But there's nothing new to learn beyond level 4, so we'll stop our discussion there. These are the energy levels. These are the rungs on the ladder that they showed you. So, an electron could be down here. Whoop, I lost my cursor. An electron could be down in level 1, right in here, or it could jump up to level 2. It would have to absorb energy to do that. It could jump up to level 3 or 4 or 5 or 6, and we're going to ignore those. But the electron can jump from one level to another. And that's Bohr's model. Now, what Schrodinger's model does for us is takes these levels and breaks them into sublevels. Now, level 1 only has one sublevel, so I'm going to draw the sublevels next to them. And that sublevel is an S sublevel, so we call it 1s. Level 2 breaks up into 2 sublevels. Oops, my drawings don't get any better when I draw them on here. So the lowest sublevel is still S, so that's a 2s sublevel. The next sublevel is a P, so that's a 2p. Okay, so notice each level has sublevels in it. Those sublevels are going to be given the symbols S, P, D, and F, but it keeps restarting each time. Level 1 has S, level 2 has S and P. So level 3, there's 3 of them, 3 sublevels. 3s is the lowest, squeezing these in, 3p, and now 3d. Okay, so again, notice the levels, different energy states. Bohr didn't know there was anything beyond that. Schrodinger realizes each level has sublevels, and those sublevels are at slightly different energy states. Now, the difference, the jump here in energy between, say, 2s and 2p is rather small. I exaggerated it a lot on my diagram so you can see it. But notice there is a difference. So in Bohr's model, you'd say, oh, an electron's going to jump from level 1 to level 2. With Schrodinger, you have to be more specific. It's going to jump from level 1, and there's only a 1s. That's the only thing in level 1. But when it jumps up, is it going to jump into 2s, or is it going to jump into 2p? There's a difference. And the electron cares which one it goes into. It takes a different amount of energy to get there. So these energy states are different, and they matter, and they'll ultimately affect the behavior of the electron. Now, up here in level 4, now you'll notice I didn't give myself a whole lot of room here, so I'm going to put them over here. 4s, 4p, 4d, and 4f. Oops. 4s, 4p, 4d, 4f. Okay? Those are now the sublevels of the levels. So notice by using just these letter and number, you can determine where you are. If I say 3p, that means level 3, the middle sublevel, sublevel p. Okay? So that's levels and sublevels. Now, further it turns out, these sublevels are broken down into smaller things called orbitals. Those orbitals aren't really, well, they're given some names, but they're not going to be important to us. So I'm going to come over to the side and draw those. Any sublevel S only has one orbital in there. So 1s, there it is, one orbital and done. 2s, one orbital and done. P sublevels have 3 orbitals in them. So there's 2p. So 2p has this orbital, and that orbital over there. Okay? So S's only have one orbital in them. 1s, there's one orbital and done. 2s, there's one orbital and done. P's have 3 orbitals. So there's a 2p here, another 2p, and another 2p over there. The difference in them we'll look at later. They're arranged differently around the nucleus. Now, 3s, well, S's only have one orbital, so there it is. 3p, P's have 3 orbitals, so there they are. 3d, D's have 5 orbitals. 1, 2, 3, 4, 5. So that's your 3Ds right there. Now, coming up to level 4, 4s, there's 1, 4p, there's 3, 4d, there's 5, and 4f, there's 7. Gotta make them tiny. Each dash is an energy state, an orbital where the electron can go. Now, these final orbitals I made here, those are the states the electrons are going to be able to go in. When we get to this in the next section of the PowerPoint, they show them as little boxes. I show them as little dashes, but whatever. These are energy states that the electron can go in. So the electron can start out here in this orbital. This is a level 1, sublevel S, then the only orbital in there. So it's a 1s orbital. That electron might jump up to right here if I give it the right amount of energy. Well, where is that? Well, it's in level 3, it's in sublevel D, and it's this particular orbital. When you get into AP Chem, you'll see that there's numeric designations for all these things called quantum numbers, and each one has different properties to it. But that orbital right there is one of the 3D orbitals. There's a total of 5 of those 3D orbitals. Let's say the electron jumped into this one. Okay? So these orbitals define unique quantum states of the electron. Another way to say that is their energy states the electron can occupy. Now, after level 4, level 5, notice what level 1 has 1 sublevel, level 2 has 2 sublevels, 3 has 3, and so on. So level 5 would have 5 sublevels, S, P, D, F, and another one beyond that, which we're not going to have to worry about. Level 20 would have 20 sublevels, S, P, D, F, and a whole bunch of other stuff. The designations after F aren't important because on the periodic table, as far as they're going to get is to F sublevels, so that's all we care about. Now, So notice though, level 1 has only one orbital in it. Level 2 has an s and 3 p's, total of 4 orbitals. That's just 2 squared. Level 3, right here, has an s, 3 p's, and 5 d's. So 5, 6, 7, 8, 9, which is 3 squared. If you add up all the dashes here in level 4, you'll get 16, 4 squared. So that's the meaning of the n squared thing. Now, each of these orbitals can hold 2 electrons in it. So this 1s orbital right here, you're going to fit 2 electrons in there and that's it. After those 2 electrons, it's full. The next electrons are going to have to go into level 2s. 2 fit in there, it's full. 2p, 2 fit here, 2 fit here, 2 fit here. Total of 6. So you see how you're going to double the number of electrons because 2 fit into each orbital. So in level 2 you have 2, 4, 6, 8 electrons fit in there. And that's your 2n squared. By the way, notice 2 in level 1, 8 in level 2, 18 in level 3. Level 4 holds 32. Now, that may look familiar to you. If you look at the periodic table, you have the first 2 columns poking up. Those are the ones that fill the S's. I'm saying this wrong. Okay, let me get you a periodic table to look at. Okay, here's a decent one. Notice now, if you go, let's look at it this way. If you go across the first row, there's two elements that can fit in there. Why? Because level 1 holds 2 electrons. You go across the next row, 1, 2, 3, 4, 5, 6, 7, 8 electrons, or elements in there. Why? Because level 2 holds 8 electrons. Level 3 holds 18. So now, if I go here and count across, you have 18 that fit in there. If you go down here and count across, including, remember, these lanthanides that fit in there, you'll find there's 32 elements. So the periodic table lines up with these electron structures we've been looking at, and that's why we say the Schrodinger equation, the quantum model, explains more things about the elements than the other models did. Another thing to look at, as I started saying before, notice these columns right here that kind of stick up. There's 2 of them. There's 2 columns. Why 2? Because S's hold 2. Those are always going to be filling S's. Now, if you look here on this side, notice it's 6 across. 1, 2, 3, 4, 5, 6. Why 6? Because P's hold 2, 4, 6 electrons. The transition metals, you might have noticed, are 10 elements across. Why? Because there's 5 D's, 5 times 2 is 10 electrons. And then the lanthanides and actinides are 14 elements across because the F's hold 7, or there are 7 F's, which hold times 2 is 14. So the periodic table is lined up with these quantum states. Now, let me show you, I guess, on the PowerPoint we're going to be using tomorrow, because they do have a decent picture of this. I'll give them credit for that. This is kind of showing how they get jumbled together, but here's level 1. There's the 1s. Notice they show it as a box. 2s and 2p. Notice again that there's 1s, there's 3 different p's. Each orbital, each box can hold 2 electrons. Here's 3s, 3p, 3d. They have them going at a diagonal instead of straight up, but that's okay. 4s, 4p, 4d, 4f. We'll get into the 5s and 6s and why they're kind of overlapping like this tomorrow. All right, so again, this is nothing really incredibly new. I just wanted to really fine-tune your understanding of what a level, sublevel, and orbital are. Again, the level is 1, 2, 3, 4. The sublevel is S, P, D, F. and the orbitals are the subdivisions of those sublevels. And we'll pick up